Your basic microprocessor executes its instructions sequentially, one at a time. The time it takes to process a control loop is measured by how fast it can execute those instructions in a sequence. This makes the clock rate and order of instructions very important in order to accomplish any given task. In addition to your robotic algorithms, the CPU has other duties such as those instructions needed to be executed by the OS, functions which contribute nothing to your robot's movements, but saddle the processor with additional housekeeping chores. In some instances, the time the processor spends executing chores in the operating system far outnumber those of your application itself, making the processor's overhead work extremely heavy to bear.
The FPGA can process your needs more efficiently in hardware since there is no operating system or overhead duties that require a slice of your process time. The Spartan 6 has internal RAM that you can customize and divide up for each function. The Spartan 6 also has internal DSP slices for signal processing of things like sensors. Build as many individual processes as you need and operate them in parallel or in a sequence, in whichever manner best suits your needs.
FPGA firmware is not software. FPGA firmware and microprocessor software are very different things. Software is a list of instructions for a CPU to execute, typically in a sequential order. Firmware for FPGAs is not a list of instructions at all, but instead a description of hardware circuits and their behavior wired up within the fabric of the FPGA. The syntax, however, for FPGA circuit description and behavior is very similar to the syntax for a software language, though it shares little in common operationally. A common syntax method for use in the description of circuits and their behavior within FPGAs is called VHDL, or Very High Speed Hardware Descriptive Language, developed by the Department of Defense with a purpose to describe the behavior of ASICs. An ASIC and an FPGA are very similar in how they can be used, with one very important difference. The FPGA can be reprogrammed in the field, aka at your desk, where the ASIC cannot be reprogrammed once it leaves the factory. If you're already familiar with writing your own software, then you'll catch on quickly with VHDL.
This is our project, the FPGA-based RF controlled vehicle. So RF controlled vehicle are called RFCV. These RFCV are known to us here as means that does not restrict motion with an original external to the device. It means that controlling the vehicle with using either cable, radio controlled, or IR. In our project here, we use the radio frequency control. And there are many functions, or what we call that, applications for this vehicle. It can be used for medical, it can be used for hazardous environments, working in deep oceans and stuff. In our project, we just made a car or a vehicle and our transmission medium. So for our demonstration, we have here the controller part. This is a CC1101 RF module. This is used to transmit data or commands from the transmitter to the receiver. And here, we also have the controller. This controller is what we call the PlayStation gamepad. Right. And then for our vehicle, we have here this. And we use as the brain of our subject is the FPGA DAO Nano, our receiver, and this is our motor driver. We also have batteries for the motors, the battery for the RF module, and here the battery for our DAO Nano. So what it does is we execute a command here, forward, backward, rotate left, rotate right, into our vehicle, and it does the job. So onwards to our demonstration. So first, we are going to make our controller. We set up our controller. We just connect the controller and our RF module. And then let's execute the RFCV controller. And then let's set up our vehicle. First, power the motor driver. then power the DEO Nano, and then power our RF module. And now we can execute command now through our commands. So as you can see, I made the object move forward, move backward, and then it also does, it's going to rotate left, going to rotate right. Okay. As you can see, we made the GUI of the FPGA-based RF controlled vehicle. So if I'm going to make the left stick move, also the GUI moves also, and the right stick. So this is our project, the FPGA-based RF controlled vehicle.
Okay.